Hi everyone, my name is Amanda, and I'm going to talk to you today a little bit about how to enable visibility for SecOps while also reducing build and runtime application security risks, and also discuss a little bit about cloud native applications and the challenges and concerns that this new technology can bring to the community. So I have here the definition of the cloud native foundation, talking about how those new technology can help to empower organizations, but also empower developers and also empower the community to build and run more scalable applications, and also in a more dynamic environment, which you can have like the needs and also the requirements can change daily, hourly, and maybe the flow into your application can change faster and you don't know how to do it. So you can have more dynamic environment and this will fit your application needs. And also some technology that came with this. We can have containers or serverless applications, and also microservices, infrastructure, and APIs can help to shape this new infrastructure and help the developers to deploy applications in a more scalable way and deploy applications more resourcefully. And also they can have a more visibility about the scale of what's happening with their environments and applications. But it also brought some problems and concerns because of as this brought something to the developers to work on, they can use this cloud native technology, they can build faster and everything. But also the security team and operations team, they might not have visibility about what is happening inside of their environment. So and also they might know that they are using cloud services, the services that they can be using there, like they are using servers or they are using Kubernetes or containers or even serverless applications, and but they don't know what is running inside of it, what is the like if it's a database of if they are running a web app inside of it and the version and everything. So and the main question will be what they need to secure, and they don't have that visibility about what is running. So how they can be able to know what they need to do to secure and to maintain this environment. And I brought here some concerns that might rise, like for the security and operations team, and also the developers team can also help on that, but this will be more for those teams to question themselves, like am I using any insecure images? Like am I only getting container image from a trusted based source? And if this source is maintaining and updating those images regularly? And also another questions will be, are all of my images in my registries and in my applications being updated? Or am I using the latest version that is on the market, or I'm using an old version that has a lot of vulnerabilities on it? And another question would be, am I using any unnecessary packages and libraries inside of the container? Am I using just a image that will be used for all of my containers and I'll build stuff on it? Or I am just tweaking to see the libraries and packages that I really need? Because with that, if I only use necessary stuff, I can reduce the place where attackers can attack, like I can reduce the surface of exposure with this. And also another question, am I measuring all my risks that I have? If I'm using secure images, if I'm not updating this, I'll have a lot of risks, I'll have a lot of vulnerabilities on it. And am I measuring everything? Because if I know what I need to protect and what I need to concern about it, that can be better. And am I monitoring everything? Am I monitoring my runtime application? Am I monitoring everything that I'm running? And am I monitoring, for example, the requests that are coming through my application or not. So maybe those questions, they can be answered, and I will show here some strategies in which we can solve some of those issues and help to best secure and to help those operations and security teams into this journey. So here I have just a plain pipeline. I just got this for example, so I can show you some steps of the way. Like if you are a developer and you are coding your app, and after you code your app, you're going to commit it to the repo. So after you commit it, that you can have some tests running on it, like some code analysis, like some static analysis, dynamic analysis, and other kind of tests. So you'll be able to see if you have any bugs on your application, if there is information that is not supposed to be there, or if you can solve those bugs before it goes to a production environment. And you'll be able to see, okay, here I found 100 vulnerabilities, bugs, whatever. So I can send this back to the developer. This could be automated. So I just send him a message, an email, a report, or a ticket. I can open a ticket and he'll be able to fix it. So this will be, the first step of this. And after that, I have my code, it's clean, it's okay. Now I'm going to build this code inside of a container. And what I can do after that, like I can do an image scanning. I can have an image scanning and registry solution that can help to see what are the vulnerabilities related to the container itself, like the vulnerabilities that I might have inside of my operation system at the container level. And if I'm using the latest version that I have, what are the vulnerabilities that I might have inside of it, the dependencies of the libraries of my code. If I have something that is more updated and I can use the latest version, that would be the best. And also there are a lot of things that solution can see. Like, for instance, if I'm developing my application and I added an API key just for testing, so I can see if it's everything working as best as I can, but I forgot to delete it. And then the solution can see, okay, you forgot that API key. It's better if you delete it. And then this go back to the developer or to the person that is responsible for the infrastructure, and he can delete this kind of stuff. Or also I can automate this in another environment. Another thing that the solution will be able to see is like if I have a malware on it, like if I have a file that has a malware on it, and if I put this into production environment, this can compromise all of the environments. The solution can scan this and see, and the developer will be able to remediate this. A case that I saw from the field, for example, was that I was in a customer and they were asking about how they can see what they have inside of the registries, because the security and operations team, they knew that the developers were using containers, but they didn't know what they were running inside of it, like if they're running an Apache or if they were running Java or, I don't know, Ubuntu. So they didn't know what were the vulnerabilities that they have inside of it, because previously they were using like on-prem server or a server instance in the cloud, but they could install an agent on it and see everything that it has and see the vulnerabilities, see the traffic flow inside of it, so they will be able to block it and to, I don't know, close ports that they weren't using. And as they were using containers, he won't be able to see what is running inside. How can he run vulnerability scan to see what he has on it? So then we show our solution that we have, and then he run that scan and find out that the developer team were using an image that has a lot of vulnerabilities. So they will be able to have that visibility that I was talking before, that this team might not have. And So after that, after I have everything scanned, I have my vulnerabilities and bugs that I can solve. I solve all of them. I got the latest version of the container image, but sometimes even the latest version may have some vulnerabilities that were not solved yet. So how I can secure this environment? I can have a runtime protection, and with this runtime protection, they will be able to secure those vulnerabilities and block this. For example, another case was a customer that he was using Kubernetes, but he installed everything. So he was able to manage his Kubernetes cluster, and the solution that he was using was a regular protection. So he will be able to install an agent inside of the server and see all the traffic that I was talking about. But now he's moving this Kubernetes cluster into AWS Fargate. That is a Kubernetes managed service, or it could be, I don't know, any managed service that he has. And now how can he can use the same capabilities that he had before. How can he use into this new environment? So he can have this runtime he can have this runtime protection, and this will be able to see the traffic that is going back and forth inside of his application. He will be able to inspect that traffic, inspect that request inside of their containers. So this is how he adapts to secure his containers inside of a cloud environment, for example. This could also be used if he was using a serverless function. He could use that runtime protection, or if he is using his container in any place, he can use that protection inside of the container and not only inside of the server or inside of the host that he don't have access anymore. So I'm going just to go through a quick demo to show you some of the technology that I'm talking about. Here is a RASP technology, a runtime application self-protection, in which, in that case, is a library that you put inside of your code. That could be, I don't know, I'm running a container, my application is running on Python, on Java, on Node.js, or another languages that can be used. So I just want to show you. Here I have my application. This application that I had is not online. I was using just for testing. But this is a container that is running a website that has forms, a few forms that he can fit. It's like a blog, and he can upload pictures and everything on it. And here I have some policies. Maybe those are what the attackers are using to attack those kind of applications. In that case, here I have a malicious payload. This could be just a malicious payload that the attacker is sending inside of your application. Like, I have an Apache vulnerability on it, and here's the CVE that you can see information about it. Here is the description. So every time this traffic comes inside of your application, the request, this technology will be able to scan it and see if this is a legit traffic or if he is trying to attack or anything. And here I have SQL injection. For example, in my website that I had a form on it, and the person could do an SQL injection from there. Like, I want to get information from your clients table. This would be an SQL injection. Another is an illegal file access. He is trying to access file that he is not supposed to. For example, here I have some rules for here, /etc. Anyone wasn't supposed to access this from my application, right? And another one will be remote commands execution. He's trying to run a command inside of application, inside of your server. And of course, again, he's not supposed to. And open redirect would be, for example, we have some cases where a bank website will be compromised, and the person goes to their website and he wants to log in. So he put his account information, his password, and everything. If this website was compromised in an open redirect case, the attacker could specify that every time that a person tries to access, I don't know, their bank website, this goes straight to the attacker website, which will look the same as his own bank website, and he will put the information there, and then the attacker can get this. Another malicious file upload is just, for example, the website that I was talking about. He can upload pictures on it, and he can put malicious content on it. So with the solution, every time he's trying to put that malicious file on it, we'll be able to scan and see if it has any malware on it or anything. Another IP protection, for example, I have a lot of attacks that are coming through my application, and this come from the same range of IP or same IP address or something. I can block it, so he will not be able to go through it. Here I have some examples of attacks that happened. That I was talking about malicious file. He tried to upload the file.txt, for example, but it has an ACAR test file just to test and see if it was blocked and everything. Remote command execution. He tried to run a script on it, and I have an SQL injection. He was trying to obtain my user's information from it, and this was not blocked because I can just send it to report or to block. I can define what I want to do. And I have malicious payload, illegal file access. He was trying to access my etc/password file, so he will be able to see the user's password information. And about the visibility that I was talking about, here we can be able to monitor it and see all the data that was coming through my application. And for example, here I have 93 requests, and from those requests, I have some remote command execution, everything. So here I can be able to see the flow and the things that I need to change, where I need to change in my code. The security team can see this and then can report back to the developers team, for example. Here I have all of my applications. I only have this for testing, so it's just not a lot of stuff running on it. And let's go back to the presentation. Let me put here. So just to wrap up and to summarize the stuff that we discussed today, the security team and operations team, from what I showed to you, he'll be able to know, I can know my risks now. I can know my flaws. I can know the vulnerabilities that I have. And if I know, I can plan what I have to do to mitigate this or to solve those issues. So I now have visibility, the thing that I was talking before at the beginning. And I can monitor, again, visibility. I can see what is happening. I can do a scan. I can have a runtime protection and see what is coming and what is going back and forth inside of my application. I can monitor it and see it, and I can mitigate. Now that I know my risks, I know how to monitor and how to see it, I can mitigate it. I can solve them. I can find the flaw and the vulnerability and the bug and everything, and I'll be able to solve it at the beginning. So for me, that was it. If you have any questions, feedbacks, concerns, anything, just send me a message on my LinkedIn or email me. I'll be able to answer. So thank you, and I hope to see you soon.